A big hello to everyone who have joined this session from various parts of the world. I'm Kris Sharma, Financial Services Sector Lead at Canonical, the publisher of Ubuntu. Today, I'm going to share my thoughts on how open source is driving business agility in financial services. Although I have applied financial services lens to the deck, the message is relevant to business and IT leaders and the DevOps community in all industry sectors. Let's take a quick look at the big picture. The financial services landscape is evolving rapidly. Financial institutions are on a journey, sustaining the business and growing the business while continuously transforming as external factors force organizations to rethink their business and IT models. In the transformation journey, enterprise agility is a key business imperative. Enterprise agility comprises of two key elements: speed of adaptation and stability. Let's take a look at some key challenges that organizations are facing in their transformation journeys. I'm sure all of you will be able to associate with these challenges. Rate of change. A lot of change is happening in terms of customer expectations, regulatory and compliance requirements, and the technology ecosystem. Because of which, most organizations are in a constant state of catch-up. Another key challenge is the need for constant evergreening and modernization of IT estate. Enter cloud and open source in this picture. Most organizations have leveraged cloud and open source technologies to address some of the above challenges. Open source is everywhere. A recent report by the Linux Foundation and the Lab for Innovation Science at Harvard highlights that open source constitutes 80% of any given piece of modern software. While financial institutions are using the power of cloud and open source technologies to tackle some of these challenges, the complexity of application landscape is growing. Financial institutions have to manage both proprietary applications and an ever-growing portfolio of open source applications within their IT organization. In any organization at a higher level, the IT budget is spent on hardware and facilities, software and services, software operations and maintenance, and business change and innovation. For most, a significant portion of their IT budget is spent in software operations and maintenance. CIO missing money is in software operations. As the portfolio of open source applications grows, it's just not about day zero, but day 1,000 and beyond that organizations need to plan for. Today, and operational challenges lead to a higher total cost of ownership. This is created by operational requirements like software maintenance, software lifecycle management, integration, and service orchestration. Let us spend a couple of minutes to understand day zero and day N operational challenges. Enterprise software operations can be messy because traditionally, operations code have been handcrafted by every organization for a particular application for their own use. With every new piece of software, it requires an in-depth understanding of that new applications by the operations team in order to deploy and integrate the new application component effectively. With ever more pieces of software to integrate from various open source publishers and with ever faster releases, there are too many configuration files with too many permutation and combinations to keep track of. It becomes extremely challenging to find the skills needed to integrate and maintain the application stack. For the last few years, organizations have tried to address the problem with configuration management. Unfortunately, configuration management attacks the wrong part of the problem. By focusing on the desired state of a configuration file, the operations team need the low-level configuration knowledge for every single application operated by the organization. Imagine a scenario where you will have enough IT budget to initiate the business change programs that have been on the back burner for years and build innovative services for your customers. Wouldn't that be great? Better software operations at a lower cost is key to turning that scenario into reality. So what needs to be done to deliver more value and drive innovation? Unleash the power of open source and the open source community. The open source community has the power to dramatically reduce costs and improve the working lives of DevOps engineers. When application code is open source, why not share the operations code too? What is needed is to transform operation code from a homegrown artifact into open source packages that can be published, consumed, shared, and updated, just like apps on your phone or packages in Linux. Not templates, but production-grade operations code that works everywhere. Imagine a world where you don't need to tweak every script or configuration file to get your scenario to deploy, scale, or upgrade properly, because those operations are handled for you in the code, created by you and the community around you. Many of you would be familiar with operators and the operator pattern in Kubernetes. Operators are software extensions to Kubernetes that make use of custom resources to manage applications and their components. Kubernetes is the critical new class of infrastructure, and we do expect many applications to work best on it. But in every enterprise, a large portion of their application estate is not currently running on Kubernetes. So any solution to the challenge of enterprise application management must address Kubernetes and all other substrates. Canonical and the open source community are building a global repository of reusable packaged ops code called charmed operators for every significant application which works on every cloud, on every kind of private infrastructure, be it physical, virtual, or containerized. A charmed operator for an application takes all the domain knowledge and expertise required to effectively operate that application and distills that knowledge into clean, maintainable Python code. So here is the big idea. Model-driven operations. What if, instead of expressing what we want from integration as the resulting configuration file, we express the outcome in a model? The model says which applications we want, on which machines or Kubernetes clusters, integrated in what way, with some high-level policy guidance. The model is just like a whiteboard. You can glance at it, at any model, and see immediately what the intention is, what standard components are being integrated, where this is all supposed to run, and at what scale. The model, of course, is associated with a substrate, such as it could be a VMware cluster or a public cloud or Kubernetes cluster, which determines where those applications will run. The model reflects further business decisions, which applications, what integration between them, how much CPU or disk, and which external systems to connect to. So in a sense, the model-driven operations capture the business intent. Enterprise software operations are costly and messy. Enter model-driven operations. Model-driven operations is a simple way of describing what software should actually do, specified from the top down. You define the services and how they relate, rather than being built from the bottom up. This enables a clean and portable expression of intent rather than a complicated recipe. Juju, the operator lifecycle manager, delivers the tools to describe your model and then turn that model into reality in a repeatable fashion on any cloud or a computing resource. Charmed model-driven operator framework, Juju, transforms your ability to integrate fast-moving open source components into large complex deployments. The move to microservices and the explosion in open source have conspired to make modern operations incredibly complex. Model-driven operators enable application operations, domain knowledge to be encapsulated in reusable packages, and the operator framework's dynamic model discovery allows reuse of those packages in widely different situations. So let us have a quick look at key elements of model-driven operations framework. Juju Controller. Now, Juju Controller is the initial cloud instance which is created in order for the operator lifecycle manager to gain access to a cloud. It is created by having the Juju client contact the cloud's API. The controller is a central management instance for that chosen cloud, taking care of all the operations requested by Juju client. Multiple clouds and thus multiple controllers are possible, and each one can contain multiple models and users. Furthermore, a controller can add to it a model which is hosted in another cloud. The Juju controller connects the Juju command line interface with the underlying cloud API, which could be a bare metal, any of your public clouds, Kubernetes clusters. It runs the API server and the underlying database. Its overall purpose is to keep that state of all the models, applications, and machines in that environment. A Juju controller could be cloud specific, a controller that only contains models in one cloud. And we can also have cross-cloud controllers, controllers that can manage models from other clouds. So what are applications and units? A charmed operator contains three elements, as you could see on the slide: the Juju agent, the operator code, and the application itself. An application unit is deployed software. Simple applications may be deployed with a single application unit, but it is possible for an individual application to have multiple units running in different machines. For example, one may deploy a single MongoDB application and specify that it should run 3 application units, so that the replica set is resilient to failure. Internally, even though the replica set shares the same user-provided configuration, each unit will be performing different roles within the replica set as defined by the charmed operator. The charmed operator, simply we call it as charms, contains all the instructions necessary for deploying and configuring application units. So let us look at the flow. The administrator interacts with the command line interface, which talks to the Juju controller. The controller then talks to the agent in the charm, which invokes the charm code to manipulate the application. The controller emits lifecycle events, some in response to the command line interface commands, some on schedule, or in response to the system cloud events. Now, the charmed operators are publicly available at charmhub.io and represent the distal knowledge of experts. Charmed operators make it easy to reliably and repeatedly deploy applications across many clouds. allowing the user to scale the application with minimal effort. Integration code creates the most friction to upgrades and new components. We know that. Software integration is slow, it's hard, and then you are stuck with it. Legacy integration and operations code makes it difficult to drive change in an enterprise technology stack. Every change requires detailed consideration of the rippling consequences in custom operations code, most of which was not written by the current DevOps team. The result is a tangled mess of operations code that is only ever used inside one business, perhaps even within just one part of the business, by a small group of operation engineers. Enterprise software, as we know, is integrated. It is the integration code between the application that glues particular versions of software in place in the legacy estate and prevents the fluid evolution to the new versions or substitute components over time. The open source community solves this problem and makes integration code a first-class element of the Juju operator lifecycle management. Don't manage applications in isolation. Instead, model rich application graphs which reflect the real integration of all the different applications in your estate. Integration code is packaged in the operator and can be shared and reused in multiple parts of the business and across multiple scenarios. Juju models integration explicitly. Let us take an example of an application, Mattermost. Mattermost is an open source collaboration platform used by many enterprises. Mattermost is just one of the many enterprise applications within an organization's IT estate. Mattermost needs PostgreSQL database as a backend. Simply put, it needs to be integrated with Postgres application. Then there is PostgreSQL Charm, which has an endpoint that offers Postgres database. Charms contain the necessary intelligence for connecting different applications together. These inter-application connections are called relations, and they are formed by connecting the application endpoints. Now, an application endpoint is used to connect one application to another application to form a relation. Here, the Mattermost charm has an endpoint that can use a Postgres database. Integration of these two applications in the model-driven operation world using Juju and charmed operators is as simple as one single command: Juju relate PostgreSQL Mattermost. In the world of model-driven operations, the integration code is reused and the integration is explicitly defined. So let us look at a much more complex scenario. Kubeflow. Now, Kubeflow is a free and open source machine learning platform designed to enable machine learning pipelines to orchestrate complicated workflows running on Kubernetes. Kubeflow includes 20 plus applications or microservices that have to be integrated, configured, managed, and upgraded. One would agree that day zero and day n operations of Kubeflow can be quite challenging. The charmed operators and Juju, which is the operator lifecycle manager, helps manage the complexity of deployment, integration, and management of the various microservices. Now, how does it do that? Respond to complexity with composition. The complexity is handled by breaking the complex scenario into small composable operators that do one thing and do that very well. We look at the dependencies within applications and declare them in the model. A model is a workspace that facilitates composition. It provides organizational view of all the operators, abstract view of the underlying infrastructure, service isolation, and access control. Let's reuse the Kubeflow example here. The Kubeflow is a really interesting MLOps platform. Think about it as a factory for data science. There are lots of things that can be integrated into Kubeflow. There is no one correct topology or an application graph. It depends on what you want to do. Universal operators help create different topologies to address different scenarios, thus enabling the fluid automated composition and integration. Model-driven operations capture business intent. A business scenario may be made up of several models, each on a different substrate. This enables the business to place application across multiple different compute environments. A single scenario may be spread across models on 2 public clouds, a private cloud, a Kubernetes cluster, bare metal servers, or a mainframe. The scenario captures all 4 aspects of the business intent. Which applications, which substrate, what capacity allocation, and what systems need to be integrated to the rest of the IT estate. This high-level application modeling makes operators easier to use at scale in the enterprise. So you have got Kubeflow, you could have a model for big data, you've got an OpenStack. High-level application modeling allows you to have several models on different compute environments across different environments. Juju and charmed operators enable a universal view of application operations. One can consume machines on demand. Your applications can run on VMware, OpenStack, public clouds, or Kubernetes. All applications can be integrated in the same way. The relationship and transport layer abstracts away the substrates that the things run on. Model-driven operations enable a software-defined full stack and cross-stack application operations. The bottom line, software-defined everything for applications and the infrastructure layer. Let us quickly explore a real-world scenario to appreciate how Juju and model-driven operations is transforming enterprise DevOps. A lot of financial institutions are moving towards hybrid clouds. With Juju, organizations can deploy, integrate, and manage Kubernetes containers or traditional VM native applications seamlessly across hybrid clouds. Juju drives day 0 through day N operations in your complex environment. The next few slides extends and builds on the concepts that I have shared earlier with you in the previous slides. So you have got a hybrid cloud running workloads comprising of enterprise applications, open source databases, monitoring applications, and so on. Could be running on Kubernetes clusters, on public cloud, on your private cloud, and then also on VMs. In the earlier slides, I had touched upon charms and various elements of the operator lifecycle management that we call it Juju. Juju uses charmed operators and the lifecycle manager to control the deployment, upgrade, integration, management, and operations of those workloads across your hybrid cloud. In the hybrid cloud scenario, Juju cross-model relations allows applications in different models to be related. Juju acts as a thin layer on the top of your infrastructure that allows all your operation code to talk to each other. That eliminates a lot of problems that conventional configuration management systems have in dealing with diverse infrastructure. Charmed operators offer perfect reuse of operations code. They do so through packages that enable full lifecycle management out of the box. This includes the ability to readily manage lifecycle events, workflows, and actions. Model-driven operations and Juju have gone a step further, enhancing and automating integrations to address lifecycle changes across scenarios. This is made possible through the combination of Juju and Charmed operators. Simple Juju command enables your operations team to manage applications and scenarios rather than fixating on configurations. With Charmed operators, you not only deploy or manage individual applications, but you relate them to one another in the model to handle scaling, the management, the cross-service dependencies. Your application model defines which applications provide a service and how they interrelate. Models, cross-model relations, the model-driven operation gives you the control to handle deployments and operations at scale across hybrid clouds, whether it could be through a command line interface or a visual tool such as the Juju graphic user interface. Model-driven operations allows organizations to shift from configuration management to application management. Save your team endless hours of script management. Deploy, integrate, and manage applications across multiple Kubernetes or VM environments. Build complex environments frequently. Manage applications and services across multi or hybrid clouds. Managing the day zero and the day n operations at scale, and thereby minimizing your operational costs. The bottom line, take control of all your applications, infrastructure, and environments. Testing, continuous integration, debugging, observability, traceability are all critical capabilities in distributed systems design. Mechanisms for testing are essential for high-quality code. The Charmed operator framework enables unit testing at the code level. As a community, continuous integration and testing of operators across a range of substrates and scenarios ensures a high standard of quality in the portfolio. If operations code is open source and reused, we would gain the same pace of innovation and acceleration in operations that we have witnessed in applications over the past decades. So reuse across business units, across scenarios, across clouds. Reuse is the key to ops code quality. Open source operators results in faster improvement, richer functionality, wiser operator behavior, and better integration. Better operators through open community standards will improve DevSecOps for widely used software. In conclusion, open source and model-driven operations drive enterprise agility. Learn more about model-driven operations by visiting juju.is, charmhub.io, and please come to the website ubuntu.com/financial services if you have any questions and would like to share your thoughts. I'll see you soon in the network room too. If you would like to discuss model-driven operations in detail, please feel free to reach out to me and I shall connect you with various teams within Canonical. My email address is kris.sharma@canonical.com. Thank you all for being a wonderful audience.